Hello, good morning. Welcome back to my YouTube channel. Again, this is Mr. Santos Capelan Jr. Always wishing you a good day. Now, today, what I'm going to do is to answer some of the questions of my subscribers and the people following my tutorial. Now, shout out to Mr. Asif Mohammed Farouk. Now, we have a question regarding my. We have two questions here. The question is, let me check first. Okay, let me show him some of my demo board. Okay. To answer Mr. Farouk's question, I would like to show him my demo board. Okay, now let me go to the full screen. Okay, okay, now Mr. Ashraf Farouk, Asif Mohammed Farouk. Okay, question of Asif Mohammed Farouk is how, let me read it. What is the protocol or the technology we use to communicate from one DDC to another DDC? Okay. So first question is, what is the protocol or the technology we use to communicate from one DDC to another DDC? As you can see here in my demo board, okay, so this is my automation server. Now, okay, this is the automation server. Now, I have 5 IO modules, okay, these are 5 IO modules. Now, these 5 IO modules are connected to my automation server through this cable, okay, as you can see, this black cable. Okay, then it will be connected to one of these. It will be connected here. Then connected to the first IO module. Then this IO module is connected to the next IO module. Then this IO module is connected to here. Okay, as you can see here. So these IO modules are communicating through this IO bus cable. Okay. Now, as you can see here, I have here 3 other DDC controller or backnet controllers. Okay, now these 3 DDC controllers are communicating to my automation server through this cable. As you can see, this cable. Okay, so this cable is backnet MSTP. Okay, so the cable is RS485. So DDC to DDC from my automation server, network control unit or NCU. I have one, as you can see here, this is the backnet MSTP cable going to one of my backnet controller, then it will go to the next backnet controller, then it will go to the next backnet controller. Okay, so it is connected in a bus. Okay, so uh, bus technology or bus protocol. Okay, then using RS4 cable, then the communication protocol is, okay, the network protocol is bus. Okay, then the communication protocol is backnet MSTP. Okay, so from one DDC backnet controller communicate through this backnet MSTP network connected to my automation server. Okay, so that is the answer in your first question. Now, next question is, okay, wait, escape what I did there. Okay, okay, I have done something there. Okay. Now, for the next question, let me read the next question. What is the protocol or any technology used to communicate from one DDC to BMS control room? Okay. Now, so this automation server. Okay. Now, as you can see here, I have one Cat6 cable here that is connected to the switch. Okay. So this yellow cable connected to my automation server. Then this network switch will be connected to my front-end computers, like my server and my workstation. So we are communicating through TCP over TCP/IP protocol. Okay, transmission control protocol, internet protocol. Okay, so my front-end computers will be connected to my network switch. Okay, using Cat6 cable. Then one of the port of my network switch, there will be one Cat6 cable going to my uh, automation server. Then my automation server will be connected to other backnet controllers through MS, the backnet MSTP. Actually, this automation server, you can connect also a LAN network here so that it can communicate to other backnet to other controllers which are using the LAN network. Okay, so I hope this one answers your question. First question: how a DDC controller or a DDC controller communicates to other DDC? So this one again from my automation server, I will be connecting a network here, backnet MSTP, so that my backnet controllers can communicate to my automation server. Then this automation server will be connected to a network switch using a Cat6 cable. Then my computers in my BMS room, my server and my workstation will be connected to the network switch so that the link from the BMS room to my automation server, and my automation server can communicate to other controllers using BACnet MSTP network. Okay, so BACnet MSTP, TCP over IP, then to my computers. Actually, you can have several automation server that will handle several area. Okay, so those automation server will be connected to your network switch using Cat6 cable and TCP/IP communication protocol. Okay, so I hope you get the idea or you get the answer from your question. Okay, now what I'm going to do now is continue this tutorial. Uh, okay, so Mr. Rashid, then Mohammed Farouk, I guess I have given you already the answers in your two questions. Okay, so to continue the tutorial, and what I'm going to do today is answer another question from my subscriber. He is asking to what is his question? Okay, let me check the questions for today. Uh, this is shout out to what is the guy? What is the name of this guy? Noman Asgar. Okay. Hello, sir. I appreciate your hard work. Please make some tutorial on analog I/O modules. Okay. Now, again, Mr. Noman Asgar, thank you for asking this question. Okay. As you can see here, I have my automation server. Okay, this is my automation server. Now I have my I/O bus. Okay, this I/O bus will be the one communicating to my I/O modules. Now in this I/O bus, I already added one analog output module or I/O module. Okay, so this I/O module can handle 8 analog output. Let me go to. So it can handle 8 analog outputs. Okay. Now here in my UI, okay. Now here in my UI, let me edit in spreadsheet also. In my UI 16 or in my UI, let me go here, or in my UI 80, UI 8 AO4. Okay. Now, you are asking about analog I/O modules, okay? So the first one is my analog output modules, okay? Then I have here universal input, okay? 8 universal inputs, then 4 analog output. Okay, now in my previous tutorial, I've shown you already how to configure several points, okay? Like temperature input, you have first to select what type of analog universal inputs you are going to connect in a channel, okay? It could be a counter input, current input, digital input, resistive input, supervised input, temperature input. This time I'm using return air temperature, so it will should be temperature input. Okay. Now humidity sensor. Humidity sensor, my humidity sensor will be voltage input. Why? Because this uh, humidity sensor will give an output signal of 0 to 10 volts. Okay. So that's why in your uh, channel 3, you have to configure it in voltage input. Okay, now how are you going to do the engineering? So from 0 to 10 volts, you have to do some configuration, meaning 0 volts, it will be equivalent to 0% relative humidity. 10 volts will be equal to 100% relative humidity. Okay, so if in that channel you are receiving 5 volts, that it will be 50% relative humidity. Okay, so now in temperature, you have to check your temperature sensor and configure it correctly. If you are using 10K type of temperature sensor, now you have to specify the type of temperature sensor. Okay, I have shown you already this one in my previous tutorial. Okay, now for analog output, the analog output here. Okay, so I already configured here several points. Now the one I'm going to show you is the cooling valve control output. Okay, now for the cooling valve, since this is output, we will be giving a control signal to the valve actuator. The signal is 0 to 10 volts. Now the signal could be 4 to 20 milliamps, but in this tutorial, I will be using 0 to 10 volts, or my analog output modules will be configured to 0 to 10 volts. Okay. Now to give you an idea about the programming, I will be showing you my program. Let me go here. Okay, so I have here several programs for my air handling unit. Now what I'm going to show you is the cooling valve control program, so that I will give you an idea how it will be associated with the analog output. Okay, now let me edit this. So we will go to the uh, building operation function block editor. Okay, now first let me stop the share. Now I have to share my screen again. Then okay. Now so again, this is my short or small control logic program for the control of cooling valve or the control of temperature. As you know, this is an air handling unit. Okay, so air handling unit will try to deliver air in an area to provide cooling or comfort cooling. Okay, now here again in the programming we have the input processing, then output. Okay, now here I have only one output. This is the chilled water valve control. Okay, so this is the cooling valve control. So this real output will be used by my DDC. Okay, then this will be associated to one of the analog output channel. Let's say analog output channel 1. This one will be associated to that particular analog output channel. Okay, so that analog output channel will be using the output of this PID control. Now we are using this PID control, proportional plus integral plus derivative, to control the temperature being delivered by air handling unit through the valve actuator, because the valve actuator will be the one to control the flow of chilled water in the cooling coil of the air handling unit. Okay, now PID. What are the inputs? First, we have the MB, that is the measured variable. Then the data type is real. Then we have also the set point. Now set point, the data type is real. Okay, then we have the MOD, or the mode, controller operating mode, that will be integer, so the data type is integer. Now we have the gain, or the proportional gain, again the data type is real. Then we have this TI, that is the integration time or integral time, that will be in second. Then we have the derivative time, that will be in second also. Then we have the dead zone and the tracking signal. Okay, as you can see, the tracking signal will be, the output will be fed again to the tracking signal. Okay, now as you can see here, the derivative time is 0, then dead zone is 0. Now, so if derivative time is 0, now we are using only PI control. Okay, because our integral time, we have some values here. Okay, so actually this is a PID, but in this time we are only using the proportional and integral component of the control. Okay, now for the measured variable, so what we are trying to maintain here is the return air temperature. Okay, so return air temperature is the one being maintained. Okay, so this will be the actual temperature set point. Okay, now this actual temperature set point can be binded to one of the control logic program, which will determine the actual temperature set point, because we have occupied and occupied time or setting. Okay, so when it is occupied, there will be temperature set point selected, and when it is unoccupied, there will be a temperature set point selected, and it will be passed to this real input as the actual temperature set point. Okay, now for the mode, okay, the operating mode could be 0. If the operating mode is 0, then it will be off. If the operating mode will be 1, so it is normal control. Okay, then mode 2, controller output forced to Umax. Okay, now Umax, we have here the Umax is the maximum permissible signal. Again, this the data type is real. Then mode 3, controller output is forced to U minimum. Okay, U minimum permissible signal real. U min is minimum. U max is maximum permissible signal real. Okay, so here for the mode, if there is airflow, okay, I'm using here one expression block. This is if then. This A, this A, then question mark 1, colon 3. This represents if then structure. Okay, so here I'm using an expression block. As if you are watching my tutorial, in my previous tutorial, I use an expression block that produces a binary output. Now this expression block produces an integer. Okay, because gain, and no, meaning this is SPI. Okay, mode is integer. Okay, so I need an integer input here, so that I will be using expression block integer output. Okay, so but my input is the supply fan airflow. Okay, so I'm checking if there is an airflow, meaning the air handling unit is working, there is airflow, sensed in the across the fan. So meaning the fan is delivering air. Now it will be fed to this expression block. Now what is this expression here? If A, then 1, else 3. So meaning if this airflow is 1 or true, then the output of this will be 1. So what will be that mode? Mode 1 is normal control. So it will, our PID or PI control will be having a mode of 1, which means normal control. Now, let's say if there is no airflow, so if A is true, mode is 1, else if it is not true, then mode will be 3. So this one, so if there is no airflow, the output of this will be 3. So what is 3? Controller output force to U minimum. So U minimum, our initial value for our U minimum is 0. So meaning if this, if the air handling unit is not working or there is no airflow, the mode of this controller will be 0. So the mode 0 will be off. So the output here will be 0. Okay. The output will be 0. Then it will be fed to our analog output channel. Then it will feed 0 volts to our valve actuator. Then the valve actuator will close. Okay. Now, let's say this is 1. Then the mode will be 1, normal control. Then based on the different inputs, this PI controller will produce the necessary output. Then it will be fed to our analog output channel. Let's say it's the analog, the controller output here is 75. Then it will be fed to our analog output channel. Then it will give uh, around 7 volts to our valve actuator. So the valve will open around 70% opening. Now, if the output here is 100, then it will be fed to the analog output channel. Then that analog output channel will produce 10 volts. Then that 10 volts will be fed to the valve actuator. Then the valve actuator will open 100% to allow more chilled water in the cooling coil of the air handling unit. Okay. So for the gain, as you can see here, proportional band, we are using here parameter value real 100. Then it will be fed to an expression real or expression block. Your input will be negated, or it will have a negative sign. Then it will be divided in 100. So whatever is the output here, it will be fed in our gain. Gain is real also. The data type is real. Now for the integral time, we have the initial integral time PBR 100. Then again another expression block. This time the input will be divided to 100. Then you will have the output of this will be fed to the integral time. Now it will be, the integral time is in second. Okay. Now as a BMS engineer, these parameters, okay, these parameters, especially the proportional band and the integral time, you have to monitor and check the response of your cooling valve to your control. Okay, maybe there will be a time that you need to change the integral time. Okay, as an engineer, you have to check how your control program, let's say this temperature control or your valve control, respond to the real scenario. Okay, maybe you will see that your valve is not, the valve is erratic. Maybe it's keep on opening, then closing to let's say it will open 100%, then again it will close to 0%. It's not staying in one opening that will try to maintain the set point. Then you have to check your control parameter. Maybe you have some problem with your I mean, you need to adjust your integral time, okay? So just try to observe the response of your uh, valve or your valve actuator to the real scenario in the field, okay? So again, I guess I have given the answer to the question of this. Who is this guy again? Uh, Numan Asgar. Okay, Numan Asgar. Shout out to Numan Asgar. This is the control logic program for controlling the temperature being delivered by a running unit. So in order to control the temperature, you need to control the valve or the cooling valve through the use of valve actuator. Okay, so your control program will be fed to the analog output of your AO module that controls the valve actuator. So from your PID control, the output of that controller will be fed to your analog output channel wherein your valve actuator is connected. Now the valve actuator will receive 0 to 10 volt signals corresponding to the output of this PID control. Okay, so once again, guys, I hope I have given you the answer to your questions, and thank you very much for watching my video tutorial. And again, if you are new to my channel, please don't forget to subscribe, and you can always click the notification bell so you will be notified if there is new tutorial in my channel. And again, I will really appreciate those followers who are asking questions, so at least I can give you an idea how are you going to solve some of the problem that you will encounter in your work, especially in the BMS. Then again, I'm not claiming any expertise here. I'm just trying to share what I have learned in my previous experience. Again, God bless us all, and bye for now.